Hi everyone. Our presentation focuses on the evaluation of success factors in determining the impact of biomedical engineering on neurosurgical operations. Let's take a look at the presentation outline. First, introduction, methodology, problem definition, application, result collection, and reference. Then, introduction. Biomedical engineering applications play a critical role in neurosurgical operations. Physicians, well trained in biomedical devices and the correct device selection can significantly reduce surgical risk. The integration of engineering application into the healthcare system has led to solution for many clinical problems and the emergence of numerous alternative treatment methods. Over time, biomedical engineering studies have resulted in the development of powerful medical device design, medical imaging technologies, and many innovative systems used in surgical procedures, all of which have impacted clinical and surgical processes. For example, robotic surgical system, deep brain stimulation, vagal nerve stimulation. Methodology. Firstly, we will start from physics logic. Physics logic is unlike the strict 0 and 1 structure of classical logic, is a mathematical apparatus that takes into account arbitrary and intermediate values. The membership of an element in a set is not expressed as a definite yes or no, but rather as a degree range. And spherical fuzzy diameter. Spherical fuzzy diameter is an advanced analytical method used to more precisely measure cause and effect relationship between factors in uncertain environments. It expresses the unstable and uncertainty in expert options using a three-dimensional spherical fuzzy structure. As a result, it creates a clear influence diagram, we can say RNRM, showing which factors are more influential and which are more dependent. It's a methodology, spherical fuzzy diameter steps. We start by defining the initial direct reduction matrix using spherical fuzzy numbers. Next, we measure the distance between these fuzzy numbers and convert that value into a clear single score. Then direct matrix, then total relation matrix, and finally we determine the cause and effect vectors from the total matrix to understand which criteria are the main influence, causes, and effect. Problem definition. Which biomedical system has the most significant impact on neurosurgery? Or is there the right production and efficiency in the right field for biomedical system? We don't know the importance of system in biomedical engineering in neurosurgery is well known, but it is unclear which biomedical system has the most significant impact on neurosurgery. As a result, inefficient healthcare systems are created to the inability to play the right strategy for the neurosurgery department in any hospital. In determining the impact of biomedical engineering on neurosurgery, the effectiveness of currently used system will be evaluated, and priority criteria for future innovative solution and system will be established to ensure correct production and efficiency in the right area. And this study comprehensively examines the factors influencing the success of biomedical engineering applications in neurosurgical operations. For this purpose, criteria were identified based on literature review and export options. The spherical fuzz dimensional, or we can say decision-making trial and evaluation laboratory method, was used to evaluate the relation between these criteria and their effect on each other. Throughout this study, it can be understood that biomedical engineering solutions are indispensable for the success and safety of neurosurgical operations. By understanding biomedical system and the technological criteria that contribute most to surgical success, experts in healthcare system can be more informed and secure decision regarding device selection. Now we can see success factors in determining the impact of biomedical engineering on neurosurgical operations. 28 criteria were identified based on a literature review and expert options. In the final stage, expert options were also collected through surveys conducted in public and private hospitals affiliated with the Turkish Ministry of Health. By combining the results, 28 factors were compiled under 5 headings within the service quality model. Application 28 criteria were identified based on a literature review and expert options, and data were collected through surveys administered to experts to evaluate these criteria. Spherical fuzzy dimensional is my application. Firstly, directly matrix and total relation matrix, and R plus C and R minus C we can see from next page. It's spherical fuzzy dimensional steps, and we can see from there plus and minus, so cause and effect we can see from this and this effect, and other this is cause. Results, cause factors, effect factors, most important factors. We can see from there cause factors is appropriate clinical simulation, remote surgical access, digital information platforms. And I think most important factors is equipment calibration and standardization, complication and recovery time, surgical risk, and assurance. Conclusion. The study contributes significantly to the literature by utilizing an advanced hybrid model that integrates the spherical fuzzy diameter method to evaluate surgical decision-making process, which are traditional fractal with uncertainty and complexity. This approach expands the boundaries of uncertainty management technique used in the literature by modeling the ambiguity in expert options not only through membership degrees but also through non-membership and hesitancy degrees. This methodology provides a robust framework for complex cause and effect analysis, especially in interdisciplinary and high-risk domains like medicine and engineering. Furthermore, this is one of the rare studies that systematically examines the interaction between biomedical engineering application and the clinical outcomes of neurosurgical operations. Consequently, this research allows us to clearly observe the specific criteria through which biomedical engineering is most closely linked to brain surgery operations. Conclusions. This study provides a methodology contribution by anticipated spherical fuzzy diameter and reference. Thank you for everything.